Hello and good afternoon. I guess everyone had a heavy lunch today, so just quick stretching of hands. Who is working with QSAR? As was showing of hands. Okay, so who is building his own QSAR descriptors or something like that? Okay, I guess not. Okay, good. And who tried to implement a QSAR model before from a paper and failed to do it? Okay. Well, most people did. So, all right. So, we are a company called eAdmet. We are a new company incorporated just last September in Munich, Germany, and we are a spin-off from a big research institute, the Helmholtz Center in Munich. This is the German Research Center for Health and Environment. We offer a platform called OCHEM, and this is a QSAR platform, QSAR modeling platform. It integrates a database of measured properties as well, together with the algorithms for machine learning and validation tools for applicability, domain, and reliability estimation. So about our platform, the platform was developed during the last 3 years by funding from the German Ministry of Health and Research and Education. We also received funding for the next 2 years together with the VC funding from the company itself, and the company decided to keep the public version available, which was just launched. And we would maintain it during the next years as well. This comes as a next platform after the VCC lab, which some of you might be aware of. It would take over the old system completely. What's very important is that it is free for everyone to try it for academic non-commercial use. And as we said, we are committed to maintaining it. If I go quickly through the modeling workflow, so you start by collecting your data. Our database already have 200 or more than 250,000 measured properties. Every single data point is correlated with a reference in an article in a journal, and this is a prerequisite for adding or uploading any data to our system, that you have to provide the reference for that. We have these 375 different properties stored with their units. So property would be like any measured property for an endpoint, like IC50, even physical-chemical properties, boiling point, and so on. And we store the data with their conditions, because sometimes without a condition, it would be hard to compare or combine data in a QSAR model. So you have, for example, IC50 measured at this pH for this kind of bacteria with that buffer, and so on. So all the conditions are saved, and the system automatically also converts between different units. So you have the data stored in the database in their original format as it was in the publication, with the unit that was used in the publication. And if you decided to combine data from different publications, then you need to convert them to one unit for modeling, and the system would do that for you. Second thing is to calculate the descriptors for this data, and we incorporate 18 different descriptor packages. Well, there are 18 or 20 depending on how you count different versions of the same descriptor package. So you would find the very famous, even commercial descriptors like Dragon descriptors, Isida, Kmaxon calculators, of course. So 18 different descriptor packages, all of them incorporated, where you can select to calculate any or all or some of them for your measured properties for the compounds. Some of the descriptors are 3D descriptors, and the system automatically handles the 3D generation using also Corina or Corina and other tools as well. So then we go to the algorithms for building the model, and we implement different machine learning techniques, multiple linear regression, artificial neural networks, support vector machines, key neighborhood, and so on. So you select whether you want a quantitative model or you would like to have a classification model, and so on. And of course, you can do validation, because a QSAR without a validation, how good is it? You can select to have internal or external validation set. So after setting up your model, all of that, you send it for calculation, and we distribute your calculation on around 200 computational server, and we provide you the result. So where does Kmaxon fit in the whole framework? So we use Kmaxon in a couple of places. First, to standardize our molecules, to handle issues like aromatization, de-aromatization of the chemical structures, to handle different transformations, because, so some descriptors require an input of, let's say, the nitro group in a certain format. Some descriptors will not be able to handle salts and so on. And we use like desalting options and from standardizer and different transformations for the molecules. Okay, and we also, of course, implement the different calculators from Kmaxon. So there is a different naming convention. Kmaxon calls them Kmaxon calculators. We call them descriptors in the QSAR concept. And then the post-processing of the descriptor, where we do the correlation matrix and remove the redundant descriptors from different packages and ones that are not correlating. We also do principal component analysis. Well, we don't have time, but this is a sample of a model calculated by Kmaxon descriptors, where you can see the R square and Q square for both training and test sets. And you can also examine the applicability domain of your model. And all that are available online, and you can share it with your colleagues. I would be available on the table outside on the left door, and I would be happy to answer any questions. Thank you very much.